Hi guys, welcome back to Beginner-Techies. In this video, I'm going to discuss about empty slot problem. So let us go through the problem description first, then we can discuss about the solution approach. Right? Right, so let's understand the problem description over here. So we have a garden with n slots. In each slot, there is a flower. In each slot, there is a flower. The n flowers will bloom one by one in n days. Right? The n flower will bloom one by one in n days. In each day, there will be exactly one flower blooming, and it will be in the status of blooming since then. So in a particular day, only one flower will be bloomed, and the status of that flower will be forever. Like it will be bloom forever. It will never be unbloom again. Right? So we have n slots given in a garden, and each slot there is a flower, and the n flowers will bloom one by one in n days. So n flowers, n days. In each day, only one flower will be bloom, and the status of that flower will be bloom forever. So here we have an array. Flowers consist of number from 1 to n. So one array will be given as an input. So in that array there will be n numbers. N numbers mean n flowers, and each number in the array represent the place where the flower will open in that day. Right? So the array of integer will represent the place where the flower will open. Means where the flower will bloom in that day, will open in that day or bloom in that day. Okay, so here the example is flower I is equal to x, means that the unique flower that blooms at day I will be at position x, where I and x will be in the range from 1 to n. Right? And also given an integer k, you need to output in which day there exists two flowers in the status of blooming, and also the number of flowers between them is k, and these flowers are not blooming. So k integer is given. K is it could be any number. So the output would be like the output would be there are two bloomed flowers. Like there are two flowers, and the status of those flowers are blooming. Okay, first flowers. Let's suppose we have three flowers, three slots. First and third flowers are blooming. Okay, and in between there is one flower which is not blooming. So in that case, we have to find the output is like if the flowers are blooming, and in between if there is any flower with, like if there is kth flower which is not blooming. So this is the condition we have to, like based on this condition we have to get the output. Like the flower should be bloom, and in between the blooming flowers we have to see if there is kth flower which are not blooming. So this is what we have to find out. If there are multiple answers, choose the smallest. If there is not such day, output would be -1. Okay, so let's understand these examples. We have this 1, 3, 2. Right? So there are three flowers, right? 0, 1, 2. So 1, 2, 3. Three flowers we have, and 1, 3, 2 is the we can say these are the slots on day 1, slots on day 3, slots on day 2. Like we can, in other words, we can simply consider it as days. This is the first day, this is the third, this is the second day, and k is equal to 1 is given. So how can we get the output? So here on the day first flower will be bloom. Now second flower will be bloom on third day. So third flower will be bloom on second day. So third and first flower will be bloom, and in between them there is a flower which is not blooming, and the number of not blooming flower is k, and k is equal to 1. So in that case, the output will be 2. So there is 2 flower which is blooming, and between those 2 flower there is 1 flower which is not blooming. So this is the output we have to find out. Here if you see this case 1, 2, 3, 4. So this is a sequentially, like on day first flower will be bloom, second day second flower, third day third flower, fourth day fourth flower, like this, and k is equal to 1. So we will not get any such a condition where 2 flower is blooming and in between them there is k flowers are not blooming. So the first 2 flower, so here if you see the first 2 flowers to open are next to each other. So let me draw an example over here so that we can get a better clarity, right? So here, right, so we should call it as slots. Slots is given 1, 3, 2. Right, so the first thing is we have in slots. Second thing we can consider in, okay, right, and k is equal to 1. So we have to find out the what? We have to find out the condition where 2 flower is blooming and in between them there is k flowers which is not blooming, which are not blooming. Okay, right. So here if you see the flowers is equal to 1, 2, 3, and these are the days 1, 3, 2. So days are 1, 3, 2, right? So this is the mapping we have. So on the first, right, so the first flower will be bloom at day 1. So if we consider this box here, on the first day this is the flower, okay, this is the flower, first flower, second flower, third flower. On the first day first flower will be bloom, okay, right. On the second day third flower will be bloom, right. So this is still not blooming, this second flower, this is still not blooming. So in this case, sorry, right, so this is still not blooming. So in this case, since we have these 2 flower is blooming, the status of these 2 flowers are blooming and the second flower is not blooming, and this is only 1 flower, right, which is equal to k, only 1 flower which is equal to k. So this is satisfy our, so this case is satisfy our condition. So in this case we can get the output is 2. So total 2 flower which are blooming, and there is 1 flower which is not blooming. So the output will be 2. This is the output. So let's see this example. We have another example, right? So 1, 2, 3, 4, and k is equal to 1. So if we see these boxes, 1, right, 1, 2, 3, 4, these are the flowers, okay, these are the flowers, and these are the days 1, 2, 3, 4, these are the days, okay. So first flower will bloom at first day, second at second, third flower will bloom at third day, fourth flower will bloom at fourth day. So the status of all the flowers is in blooming state. We cannot see any such cases where we can get that, where we can get this condition where two flowers are, three flowers are, or four flowers are blooming, and in between them there is k flowers which is not blooming. So we cannot see any such cases. So in this case, the output will be minus. These are the cases we have. So what could be the possible approach? We can have naive solution, naive approach, but I will not recommend this. This will be the complexity is not better if we go through this naive. And second is sliding window. Sliding window. I'm more concentrating about this sliding window technique. So this is what we have to apply to solve this problem. Right. So we will go with sliding window technique. Let's suppose we have k is 1, and the example is already given, this 1 3 2. So in this case, what is the possible window we have? Right. So our possible window would be like this is our index. So index plus what? K is the size plus 1. This will be our window size, right? This will be our window size. Yeah, so I use these two variables, left, right. Right will be k plus 1 and left would be 1, right? And here this would be the sliding window technique. I usually use a hash map. So if we think about this hash map, in this hash map we will add the days. This is the days, this is the flower. Let me make it little clear. Sorry. So this is days, this is flower. Okay, so first day first flower, second day third flower, third day second flower. This is the map we have to use. Okay, so this way we can simply populate the data into the hash map, right? Okay, so right, so this is our window size. Okay, right. So in the map we have to check if map dot get index greater than map dot get left. This is the first condition we have to check, and the second condition is map dot get index greater than right. If these two conditions are satisfied, then it should be continue, and the base case would be what? Index is equal to right. So in this case we have to calculate min days, right? We have to find out the min days, right? So this is the base case. Otherwise we have to expand the window. So the window would be expand with right is equal to index k plus 1. This way window would be expand. This is the step we have to follow while writing the code to solve this problem. Okay. These are the steps we have. Okay, so let's solve this problem. Right. So let me create one class over here in the sliding window. Okay, empty slot. Okay, empty slot. Right. Okay, so we have to create this main method as well, right? So let me just take one int bloom. This is the array we have 1 3 2, and we have this k is equal to 1. Let me right, and here we sys out get slots. Slots here we have to pass this bloom and k, right? So let me create this method over here. This should be integer. Okay, right. So first I will create this map. Bloom flower map hash map. Right. So here as I so here we have to add all the flowers into the map. I less than what? Bloom dot length I plus plus. Okay. So this map is actually day flower map, right? Day flower map. So in this map I will add all the flowers. I will map all the flowers with their respective days. Okay, so here this is bloom of I, and this should be I plus 1. So this I plus 1 is actually a flowers, and this bloom of I is actually days. Okay. Right. So here we have to define results, and result should be integer.max. This should be integer, right? I have taken this max value because we need to find out the minimum case slots, right? We have to find out the minimum case slots, so that's why I have taken this result as a max value. Okay. Now we have to define left is equal to 1 and the window size right is equal to k plus 1. Okay, and there will be one index values while right less equal to n. N is what? N is actually bloom dot or length, right? So here we have this loop. If day flower map dot get index is equal to greater than day flower get left, right, and day flower get index have to compare with right as well. Here this index should be increment with 1, because we cannot check with index is equal to 0, right? In that case we will get null pointer exception, because we have added this like the flower with I plus 1. So that's why we need to increment this. Okay, so this should be continue if this is the case. Otherwise, if index is equal to right, so in this case we have to calculate the result. We can simply use the math library to get the result here. So since we need to get the minimum here, and from this we have to get the max, right? So this should be day flower get left. So this left is actually we can say this is the starting day, and this is the day flower map is the current day. This should be right. This is the previous day and this is the current day. We can consider this way. Okay. So in between we have to find out the which is max. So here if you see if you just see this example, so this is the first, right, and this is the second. So we have to check we have to take the max value. So in this case the max value is 2, so that's why we have to compare here min and max. So here we have to get the max value. Okay, right. So otherwise we have to update with this index, and this right would be expand with index plus k plus 1, right? And here we will check if result not equal to integer dot max value, then we have to return result. Otherwise we have to return minus 1, right. Okay, so let me run this function. So here we got the -1. Okay, so I did one mistake over here. This should be day flower map dot get. This should be right, because we have to check into the map. We should not directly compare with this right value. It should be compare into the map itself here, because we are checking the flower, right? So let me run it again. So here we got the 2. So 2 is actually 2 is expected output, right? So let me just change this input 1 2 3 4. Okay, k is equal to 1. So in this case we should get -1. Yeah, so we got the -1. So let me check with this input 5 3 1 4 2. Okay, and k is equal to 1. So in this case we should get 2. Okay, yeah, so we should get 2. Let me run this. Right, we got the 2. So we are able to solve this problem with the help of sliding window technique, and we got the optimized solution. The time complexity of this solution is O of n, right? There is a lot of another problem with a similar pattern, and there are similar kind of questions in the lead code. We can solve those problems and get the confidence, right? Thank you for watching. Bye bye.